Hi everyone, wanted to give you an update here on my generator. I was rebuilding the rotor, and I do have that finished now. And what I'm holding here is the magnets that I have installed inside that rotor. They are 1-inch N50 Neo magnets, and these magnets are extremely powerful, very dangerous. Let me pause the camera, put this magnet away now. Okay, here's the new rotor, and what it is I used two 1/2-inch plywood pieces here that I glued together, and the magnets are embedded in that. I don't know if you can see the magnets now. I guess you can't see them from the other side there. Anyways, they fit exactly within, embedded completely in this piece of plywood. And there's a total of 8 magnets on there, and it's very heavy. It makes a heavy wheel. I wouldn't want to use any bigger magnets than that, but like I said, they're very, very powerful. And you see here a couple of screws here. These are brass screws that I had to put in to balance the rotor. So the rotor's fairly smooth. And I'm getting some good results, I believe. And there's a coil that's ready to be tested with this new rotor. So let me start the unit up and see what we get. So there you have the rotor turning, and it's quite amazing how quiet it is, really, for such a heavy rotor. Quite impressed with my ability to make that rotor with just hand tools, basically. I have no machine shop or anything. I don't even have a garage. Made most of this inside the home. So anyways, that's it going now, and let's look at the data. So what I've done is I've installed 2 meters. This meter is displaying the voltage that is feeding the motor. That's obviously tuned down by the variac. I'm using a higher voltage in the 80 volts area because of the weight of the rotor, and need to boost the voltage up to get that up to speed so we don't have slip. And right now at 78 volts the motor is drawing 780 milliamps at that voltage. And I have my good meter here that we're going to be measuring the voltage across a 1 ohm resistor. Here's the resistor that's ready. I have my scope probe across it, and nothing is happening right now because it is not connected. So let's go ahead and connect that, and what I'll do is I'll bring the camera here. So there's our voltage and there's our milliamps draw, and now I've loaded the 1 ohm resistor on the coil. So there is the data. So we're at about 80 volts, and we've jumped to 0.915 milliamps. And we have 2.86 volts across our 1 ohm load, and that is still climbing. 7, and there again is our shot here of our voltage and current draw. There's our 1 ohm resistor. It gets pretty hot, and I've raised it off the table here so it doesn't melt the table. And there is our waveform, and there is our data. So sorry about that, 8.5 volts about peak to peak. Our frequency is 462 hertz apparently, and our voltage RMS is at 2.88 from what the scope is calculating. And let's see what it's at right now. Oh, yeah, pretty close, 2.92, and it's still climbing. So what do we have here? We're still at 79.4 volts at 0.91215 at the most. Very nice sine wave. There's our data still. So we're pushing to the 3 volts at this time right now. We're over the 2.88. Resistor is still under load. There's still our data there for voltage and current draw. And we're at 2.96 and still climbing. So I'm not too sure why the voltage just keeps climbing. Is it because we're actually heating that resistor, and with the heat the voltage can climb because the resistance is changing? I'm not too sure. That's a 10 watt resistor. So let's look at our data here again. So we're definitely in the 2.94 volts now and still climbing, and that's what we're getting here exactly, 2.98. And what I'll do is I'll stop it, I'll disconnect it once it reaches 3 volts, and we'll look at our data here. So we're at 79.7 volts at still the same current draw, 915 milliamps. So now the software scope is saying that we're pretty much at the 3 volts, because it's staying probably quite a bit more at the 3 volts at this time. And it's interesting to see that it is an accurate software, because if we look at my quality meter here, we're exactly at 3 volts. So like I said, once we reach 3 volts, I'll disconnect the coil here. So just disconnecting this clip here. Let's have a look at the data here. We're at 80 volts at 912 milliamps and disconnected. And this is where the motor falls. About 777 milliamps. At 80.3 volts. And there you go. Everything is disconnected. No more voltage across our resistor. And there is the motor just working on its own, no load. So I'll post this quick video. We can do the quick calculations to see how well the coil is performing with this new magnet rotor. And obviously our coil was mounted on the side, so we're pulsing the magnets onto the side of the coil. Thanks for watching. Bye now.